Hello students, welcome back. So in our first lesson we discussed how we could talk about pitches in groups of one. So how do we talk about a single pitch on the staff? And to do that we needed to understand how these clefs worked, how this drawing up here works, how the pitches are arranged on it, and an understanding of the musical alphabet including our sharps and flats. So today we're going to start talking about pitches in groups of two. So how do we relate two pitches to one another? And for that, we're going to need all this lovely new stuff down here. It's not as complicated as it looks, so let's get into it. Before that, though, it's going to be very helpful if we have a better understanding of how the pitches are arranged on a keyboard, a piano. Okay, so you can do all of this just by looking at this, but a lot of people find it helpful to use a keyboard. So here's an image of a keyboard. And we know that there's the pattern of 3 black keys. This actually isn't the best image because it doesn't really show that, but there's a third black key here. And it's a pattern of 2 black keys, 3 black keys. You can find a better image if you like. And right before this first black key in the group of 2, that is the pitch C. Okay? So the white keys are all of the standard letter names. So C, D, E, F, G, A, we're going to jump down here. This one's A again, B, C, D, and again it keeps repeating. And then the black keys are our sharps and flats. And as you'll notice, if you recall that we have no B sharp and no C flat, indeed here there's no black key between B and C. So that's reflected in the actual keyboard. Okay, I'll show you how to do this math on the keyboard at the end of the video. But for now, let's just talk about it on the staff because that's how you're usually going to see it. And that's where it's going to make the most sense to do this sort of math. What we need to do this is basically to be able to count by 1. Okay? Just counting by 1. Hopefully we all know how to do that. If you don't, not a whole lot I can do for you here. So let's begin. Our unit of 1 is also called the half step. Calling 1 a half is a bit confusing, but stick with me on this. So the pitch A to A sharp. That is 1 half step. We have moved on the keyboard from, let me get the glare off, we've moved from A to A sharp. We've moved 1 key, okay? That did something odd, but we're going to ignore it. So moving from 1 key to the next, or in this case, 1 letter to the absolute adjacent one, that is a half step. So notice, again, B flat and A sharp are the same, and A to A sharp and A to B flat are both 1 half step. Okay? So then A to B, since we're skipping over this, is going to be 2 half steps, or a whole step. We're only going to talk about half steps now, but just know that it's also called a whole step. So that is 2 half steps. A sharp, B, C, 3 half steps. And so each of these numbers of half steps has a name. Okay, so 1 half step is also called a minor second. 2 half steps is a major second. 3 half steps, 4 half steps, etc. Minor third, major third. It gets a little bit strange here. So we have a perfect fourth, a tritone, and a perfect fifth in the middle. Now to illustrate that a little bit, you don't really need to have a thorough understanding of that yet, but we want to understand basically why those are different. So if I show you a major third, that has kind of a color to it, okay? I'm going to be speaking vaguely about these things for now, but it's more clear when I compare it to, say, the perfect fifth. There's your Star Wars theme. There it is. I don't know it. But anyway, so that is not as colorful as that. Okay, so that's why it's called perfect. There's a lot of math and physics that goes into that I am happy to discuss if you would like to leave a question for me. But for now, let's just accept that is the major and minor have kind of a color, and the perfect ones don't have that color to them. Okay, and then the tritone. So that has a particularly unique color, particularly ugly. Okay, that's otherwise known as the devil's interval. So it's people don't like the tritone. I think it's great. It's very useful. And actually, we're going to go on a tangent here. The tritone is basically, you could summarize all of Western classical music with a discussion of the tritone, but we'll save that for a later date. So those ones are special, but they are still counted in half steps. So our major third is 4 half steps, a perfect fourth is 5 half steps, 6, 7 half steps for each one of these. And then we have minor 6, major 6, minor 7th, major 7th. Those are all just other countings of half steps, 8, 9, 10, 11 respectively. And then our final one, the perfect eighth, an octave, that is where we get the repeat. So if I start on the pitch C and I go up to the next C, that's a perfect octave. We just call it an octave. Okay? So how do we find out what an interval is when it's written on the staff? So let's start with a simple one. If we take E and F, we count how many half steps are between those two. So if we start here, we have E, we go 1 to F. Simple. That's a minor second. So if we change it from, instead of going to F, we'll just X that out. If we go to G, it would be 1, 2, 3 half steps. So starting on E, F, F sharp, G, that's 3. So that's going to be a minor third. Now it gets a little more complicated when you start adding the sharps and flats. So let's add G sharp here. I know that's a bit ugly to look at, but trust me, it's a G sharp. So E, 1, 2, 3, 4. 4 halves. I covered that up, so let me do that like this. E, 1, 2, 3, 4 to G sharp. Okay, 4 half steps, major third. And that's all you have to do to get all of these. It doesn't matter how far apart they are. We can do that to that. And we just need to count our letters. So if you remember how to read the treble clef, you know that that is E and that is C. So we can just say 1, 2, 3, 4, 5, 6, 7, 8. 8 half steps, minor sixth. Okay? Is that right? Yeah, that's right. Sorry. With the background I have in music theory, sometimes I do it in a different way other than counting. So sometimes when I count it, it actually throws me off a little bit, but we'll get there later. Okay, so just by counting our half steps in here, we are able to name the interval. So we're able to relate two pitches to one another. Okay, so the important thing to remember is just how to do the counting. So we count a sharp and a flat once. You don't count them separately. So A to B is not A, 1, 2, 3. A sharp and B flat are the same. This is clearer on the piano. So if I pull back our picture of the piano here, excuse me while I stall, let's see. Let's start with C. C to D. So C to D, it's doing the thing again. C to D. There's one key in between. So 0, we'll count C as 0. 0, 1, 2. Major second. 2 half steps, major second. We did not count C, C sharp, D flat, D. You're counting the same thing twice there. Okay, that's when the piano becomes useful. And I really would encourage you, whenever you are trying to solve one of these, try it on the piano too. No matter what instrument you play, having an understanding of the piano is very useful. Okay, so that's a basic understanding of how to read intervals and how to name the relationship between any two pitches on the staff. It's the same in the bass clef. I've only shown it in the treble clef just for simplicity and whiteboard space, but that's the general idea of how to count intervals. Now these will come back later. We will build on top of these to get more complex structures, but for now, just units of 2.